Hi all. In this video, let us learn about application of Laplace transform to solve differential equations. We know very well that Laplace transform is a very good technique for solving differential equation problems. It will transform the given differential equation into a simplest algebraic equation. Further, we can use the inverse Laplace transform to get the desired solution of the given differential equation problem. Let us work out some example. Now solve the problem. Y double dash plus 2y dash minus 3y is equal to sine t. Given initial condition is y of 0 is equal to y dash of 0 is equal to 0 using Laplace transform technique. So the very first step we have to do is we have to take Laplace transform on both the sides of the differential equation. So let us take it. You'll be having L of y double dash plus 2y dash minus 3y is equal to L of sine t. So now using the linearity property, we can break this terms as L of y double dash plus 2 times L of y dash minus 3 times L of y of t is equal to L of sine t. Now let us use the formula for this L of y double dash and L of y dash using the initial condition, and let us use the formula for L of sine t. We can substitute them in this equation and we can simplify. So let us go for that. We'll be getting our L of y double dash as s square into L of y of t minus s into y of 0 minus y dash of 0. So in this equation, if we use the initial condition y of 0 as 0 and y dash of 0 is equal to 0 because it is given in the question itself 0, we substitute it, means we will be having is equal to simply s square into L of y of t. The second term and the third term will vanish out. And we know that L of y dash is equal to s into L of y of t minus y of 0. So when we substitute again y of 0 as 0, means the second term will be vanishing out and we'll be having s into L of y of t. And we know that L of sine t, the formula will be, it is 1 divided by s square plus 1. So we know all these three values. Let us substitute this in this equation and we will simplify and we will get what is L of y of t is equal to, and then we use the partial fraction technique and then we use the inverse Laplace transform to get the desired solution. Okay, let us substitute now. So we know that the first term L of y double dash is replaced with s square into L of y of t, and the second term plus 2 times s into L of y of t, and the third term is minus 3 into L of y of t is equal to 1 divided by s square plus 1. Now this is a very simple equation where we can check this L of y of t commonly outside. So we'll be having s square plus 2s minus 3 into L of y of t is equal to 1 divided by s square plus 1. So now let us factorize this term. So the factors of s square plus 2s minus 3 will be, we got minus 3. So 1 into 3 will be 3 and I need a positive 2 there and negative 3. So let me take minus 1 and 3. So the factors will be s minus 1 into s plus 3 into L of y of t is equal to 1 divided by s square plus 1. So now your L of y of t will be equal to 1 divided by s square plus 1 into s minus 1 into s plus 3. So this is our L of y of t. Now let us use the partial fraction technique to break this term, and then afterwards we apply the inverse Laplace transform. So now what is 1 divided by this s square plus 1 into s minus 1 into s plus 3 can be written as, since the first term is um, order of 2, we can write the numerator as as plus b, a linear format, divided by s square plus 1, or 1 powerless we have to take, and second term will be it is c divided by s minus 1 plus d divided by s plus 3. Let us take an LCM. We'll be having 1 is equal to as plus b into, we'll be having s minus 1 into s plus 3, and the second term will be plus c into s square plus 1 into s plus 3, and the third term will be plus d into s square plus 1 into s minus 1. Now first of all, let us take s is equal to 1. If I take s is equal to 1, what will happen is this factor will be vanishing out and this factor will be vanishing out. So it will be easy for me to find the value of c. So that means I will be having 1 is equal to, first term will vanish out. My second term will be c into, so it is 1 plus 1, it will be 2, and 1 plus 3, it will be 4. So the third term will vanish out. So I will be having 1 is equal to 8c, or otherwise this implies my c is equal to 1 by 8. Now let me take the next another factor as s is equal to minus 3. If I substitute an s is equal to minus 3, I think once again the first term will be vanishing out and c will be vanishing out, so that it will be easy for me to get the value of d. Okay, let us go for that. So here there is no change in the left hand side part, it's 1 is equal to, my first term will vanish out, the second term will be also vanish out, and the last term will be plus d into, so minus 3 whole square will be 9 plus 1, it will be 10, minus 3 minus 1 will be minus 4, so 1 is equal to minus 40d, and this implies d is equal to minus 1 by 40. So I got the values of c and d. For getting the values of a and b, so I can compare the coefficient of a s cube term. Actually, we can see here, if we can take this one, it is as, here one s and as. That means the s cube coefficient will be a. Similarly, here the s cube coefficient will be c, and similarly the s cube coefficient will be d. So here on the left side there is no s cube term. So if you take 0 is equal to a plus c plus d, and I know the values of c and d, so very easily I can get the value of a. Similarly, for getting the value of b, let me compare the constant. If we compare the constant now, what will happen is, let me take this orange color. If I take this one, so this b term will be here, this minus 1 and minus 3, I mean the constant term. And here again this 1 into 3 into c I will be having, then 1 into minus 1 into d I will be having, so that I can very easily, I know the value of b and d, so it will be very easy for me to get the value of beta. Okay, so let us go for that. So now let me compare the coefficient of s cube term. If I compare the coefficient of s cube term, so as discussed earlier, the left side there won't be s cube term, and the coefficient of s cube in the first term will be a, and the coefficient of s cube in the second term is c, and the coefficient of s cube in the third term will be d. And we very well know what is the value of c is, it is 1 by 8, and d value is minus 1 by 40. So it is 0 is equal to a plus, you take an LCM, it will be 4 by 40, or otherwise this implies a is equal to minus 4 by 40. For the simplification, it gives us a is equal to minus 1 by 10. Similarly, let me go for finding, comparing the constant term. compare constant terms. So when I compare the constant term, the left side you'll be having a term 1, and on the very first term I will be having minus 3 into b, and the next term plus 3 into c, and the last term will be minus d. And I know that 1 is equal to minus 3b plus 3 into 1 by 8, minus of minus, it will be 1 by 40. So that is nothing else, it is minus 3b. If you take an LCM for these two terms, it will be plus 16 by 40. So that is 1 minus 16 by 40 is equal to minus 3b. So that is 24 by 40 will be equal to minus 3b. So on further simplification, we will be getting our b is equal to minus 1 by 5. So this term actually will become 8 and this will become ended 5. So b is equal to minus 1 by 5. So we got all the four values of a, b, c and d. Let us substitute them in the L of y of t. So your L of y of t is equal to, so it is a s plus b. So the value of a is minus 1 by 10 s. Then b value is minus 1 by 5 divided by s square plus 1, and then plus the c value will be 1 by 8 divided by s minus 1, then plus 1 by 40 divided minus 1 by 40 divided by s plus 3. So this can be broken like this. Y of t will be equal to L inverse of, okay, first of all take the minus 1 by 10 into L inverse of s divided by s square plus 1. My second term will be minus 1 by 5 times L inverse of 1 by s square plus 1, and then plus 1 by 8 times L inverse of 1 by s minus 1, and minus 1 by 40 times L inverse of 1 by s plus 3. So now it is find the L inverse of each one of the term. It's minus 1 by 10 into L inverse of s by s square plus 1 is nothing else, simply it is cos t, and L inverse of 1 by s square plus 1 will be sin t, and L inverse of 1 by s minus 1 will be e to the power of t, and the L inverse of 1 by s plus 3 will be e to the power of minus 3t. So we have solved the differential equation and we got the solution as y of t. Now let me quickly refresh the steps or procedure to be followed. The step 1 to be followed is take Laplace on both the sides of the differential equation, and then use the formula of L of y double dash, then L of y dash, and then on the right side, whatever the elementary function is available, we can use it. Like in our problem, we got L of sin t. Then second step will be we have to use the initial condition which is provided in the question, and we simplify the terms, and we simplify like L of y of t is equal to, like that we have to simplify. And then in the next step, we have to use the partial fraction technique for breaking those terms in the right side. So we have to use the partial fraction technique. And the last step will be, we then for getting the value of y of t, you take L inverse to the simplified fractions. Then use the elementary function of L inverse and we will be getting our desired solution y of t. So we can very easily see that Laplace transform technique is a very effective method for solving the differential equation, especially when initial conditions are provided to us. It will be helping us a lot in finding the solution of the equation. So in the Next class, let us work some more examples of the same kind. Uh, Thank you.